Lesson 16, Introduction to the Parabola. Some people want to call that Parabola because that's what it looks like, but it's pronounced Parabola. And all a parabola is, it's a U-shaped curve that we use when working with quadratics. If you remember back to linear functions, well, that graph was linear, which it was a straight line, and that made sense because line, linear. The parabola doesn't sound much like the word quadratic, but we use it because if you take more advanced mathematics, you'll see lots of different functions and graphs that are related to the parabola, and some of them may be cones and different things. So we use the word parabola. Some teachers will call it the quadratic graph, which is, I mean, that's not wrong, but it's not entirely correct. So let's look at our learning objectives. You've got three things that you'll learn in this lesson. You're going to learn the shape of the parabola, which is U-shaped. It's not a very good U. It's got to be U-shaped. You'll learn the parts. It's going to have different parts. And then you'll use it to find the solution of a quadratic. And the first way that we learn to solve quadratics is with graphing or visually. There's a few things that you must know to be successful. You need to know domain and range. You know, that's your x and y, or your inputs, outputs. Your x and y intercepts are where it crosses the x or y axis. And you know this from before, and you know domain and range. You know what a function is. It's a one-to-one relation. Each input only has one output. In graphing, like you got to be able to graph. You got to be able to plot points and connect them. I know you can do these things because we've already done them, so this shouldn't be super complicated. There are some new terms here. One is it's your vertex. This is your turning point of your quadratic. And any time a graph turns, that's called your vertex, your min and maximum values. Well, that's your lowest or highest point of a graph. Good thing about quadratics is they only have one min or max. You get into trig functions and be slightly different, but there's only going to be one absolute minimum or maximum values with those more advanced things, but we're not doing them, so we're not going to worry about it. You need to know the word parabola. Funny little thing is I'm not a good speller, so when I have to spell it, I always think parabola, but I know that's not right. It's parabola. Your axis of symmetry, this is the x value of the vertex. So the vertex is going to be a point on the graph. You need to know quadratic. That's your x squared function. So any functions that are x squared or has an x squared in it, it's called a quadratic. Your x squared just by itself is your parent function. And finally, you need to know roots, zeros, or solutions. These are synonyms. They all mean the same thing. We just have three different ways of saying it in mathematics. Because, you know, the more words you know, the smarter person you can become. So, just once again, parabola, it's the shape of your quadratic equation. So that's a parabola. And that one, your vertex, there's your vertex, I'll write it here. That's your turning point. That's where it goes from, depending on, and let's say from left to right. So here you're going down to the vertex and you go up. So it's the bottom of the valley or it's the top of the hill. So it's once again, it's the bottom of the valley. Where's your hilltop? Your axis of symmetry, it's an imaginary line. I mean, sometimes you draw it, but we don't. It's your x value, and when you fold that parabola across your axis of symmetry, it lays on itself. So basically you can fold your parabola in half through the vertex, and finally your maximum, that's your highest point, and your minimum is your lowest point. So these are also your vertexes, right? So depending on how the graph looks, if it looks like number 1 here, I just call this one number 1. Well, your vertex is a minimum value. Graph here, number 2, the vertex here is a maximum value. And let's talk a little bit about domain and range. Remember, your domain's your input. Your range is your output. So if you got x squared just by itself, is there any way you can put a number in for x squared and get a negative number? No, because a negative times a negative is always a positive. You got 4, you got 9, you got 16. So your domain, or your inputs, your domain is, we're going to write ARN in here for all real numbers. A lot of times you'll see it as a funny looking R. It sort of looks like a parentheses symbol with a R superimposed on top of it. That's hard to type in a PowerPoint, so we're just going to do ARN, and that's okay. Your output, that's your answer, right? It's your answer. It's whatever you get. So we had this problem here. Well, our output, or our answers, were all positive. So our domain is always going to be all real numbers. And your range is going to be whatever the possible answers are. So with this given parabola, it's impossible to have a negative answer. But if we did negative x squared, well then you have negative 2 times negative 2, but you got a negative out in front of it. So you would get your range, or your possible answers could be negative. So it just depends on the equation. And sometimes we may have quadratic that looks like this. And some of your answers could be negative, some of them could be positive. And we'll look at that in more detail. There's 3 outcomes with a quadratic equation. And what we're talking about here is there's 3 solutions, or 3 solution types. Probably say 3 solution types. So there's 3 possible outcomes. You can have no solutions. And a solution, you're probably asking, well, what's a solution? A solution is where, take a note, it's a good thing to take a note on. Solution is where the graph crosses the x-axis. The solution is where the graph crosses the x-axis. So as you see here, there's 3 possibilities. One, depending on the equation, it may not even cross the x-axis. So there's no solutions. You could have one solution where it just touches the x-axis. So the solution for this one would just be 2, 0, or most often you'll just see it as 2. And the other possibility is it crosses your x-axis twice. So here, and we put these in brackets, it would be -3, +1. And it's good form to always put your smallest number first in the brackets. So the parabola has 3 options when it comes to this relationship to the x-axis. It could not touch it. It could touch the x-axis once, or it could cross the x-axis and touch it twice. Very common question. Let's look at the parent function. So x squared, that's the parent function of the quadratics. So everything we do with quadratics is going to start with the parent function. Our vertex, which is where it turns around, that's at the origin, 0, 0. And if you notice, the range here can't be -1 or anything, right? It can't be any negative number. So this has a minimum value. So no answer to x squared could be less than 0. I mean, you could have 0 squared, which is 0, but -1 times -1 is +1. 2 times 2 is 4, 3 times 3 is 9, and you can go so on and so forth. Your axis of symmetry, in this case, is just the x-axis. There's a red dotted line here. If you folded this over on top of itself, it would lay perfectly. So your axis of symmetry is x is equal to 0. Your y-intercept, once again, is 0. Sometimes you'll see it written as this. That's how I chose to write it. Nothing wrong with saying b is equal to 0. Or you could just put 0. Whatever you do in this situation, it's whatever your teacher tells you. So if you take college algebra and teacher's like, oh, make it be equal to 0 or it's wrong. Well, do that. But just realize these three things are equal answers. Zeros, which is your solution. In this case, it touches the x-axis at 0, 0. And once again, sometimes this may be written in brackets. Just it's personal preference. But there's only one 0. It only touches the x-axis once. Your domain, you can put any number into this equation. And you put any number in this equation and you'll get a positive number all the way to infinity. And this is what your work's going to look like. Your online practice, you're going to be given a graph like this, and you're going to need to identify these things. Let's look at another one. So notice, we still have x squared, but what did we do to it? That's right, we subtracted 2. So look what happened. It went down 2 spots. So that's going to change up some things. So we're going to have a new vertex. Your vertex is your turning point. Turning point. Or it's the bottom of the valley. So what you need to do for your vertex, you need to write that point here. Your axis of symmetry is going to be x is equal to some number that when you fold this graph on top of itself, fold the paper over, it lies on top of it the other side perfectly. And that's always the x number here comes from your vertex. Your y-intercept is where it crosses your y-axis. So you can either write it as xy or b equals. Either one's fine. Your 0 is where it crosses your y-axis. You can either write it as an ordered pair. In this case, you could have 2 ordered pairs, or you could put it into a bracket. It'd be x1, x2. Your domain is always going to be all real numbers. We keep asking that because it's important when you look at a graph or a function to think about, well, what numbers can I put in here? Because if you go far enough in mathematics, we're going to limit the domain in certain functions, especially in calculus. And your range, you're going to write it in brackets, and that's going to be all your possible numbers. You may want to pause the video, try it out on your own. On the next slide, I'll share with you the answers. So you should have time to work this out. Well, your vertex point here is 0, -2. So you should have 0, -2 here. Your axis of symmetry is x is equal to 0. And if this was a test, if you had axis of symmetry and you didn't write x is equal to 0, in my class, I'd count it right. Other teachers, they may or may not count it right. I think it's kind of cheeky not to, but, to each their own. Your y-intercept, well, this crosses y at -2. So -2, if you wrote 0, -2, that's good too. Your zeros, now here, it's tricky. It's not a lattice point. So we're just going to have to approximate. If you got anywhere like -1.3, -1, really -1 in any decimal would work for me, but there's two of them. Later on, we'll do the quadratic equation, and if we wanted to, we can get an exact answer. I won't show you the quadratic formula now. You just have to wait in anticipation until we get there. But just keep in mind, the reason that we will do the quadratic formula eventually is sometimes our solutions with the graph's just not exact, and we want a more exact answer. I showed you this graph because I wanted you to see the graph going down -2 spots because of your y-intercept, and that's your y-intercept. In your range, the answer to this equation could be, if you got 0 squared minus 2, well, 0 squared is 0, 0 minus 2, so you can get any number larger than -2. And that's how we write it. We have this bracket like this, -2, which is your smallest number in your domain, or in this case, it's your smallest, and it can go all the way up to infinity. And speaking of your smallest number, since we know this has a smallest number, our vertex has a minimum value. Let's look at another example. So this one, we added 2, which when you think about your parent function, this moved up 2. But do the same thing, figure out what your vertex is, figure out what your axis of symmetry is, figure out your y-intercept, figure out where, zeros are your solutions. So where does this cross the x-axis? Your domain, what are your possible answers? Possible answers. I'm sorry, not possible answers, possible inputs. So what numbers can you put in here? And then your range, that's your possible answers. And somebody caught that, and I appreciate you catching that, but it's your possible answers, or it's your outputs. So you may want to pause the video, work that on your own. Next slide, I will give you the answers. Parabola, and this one, it's the parent function added to 2. So we've got a new y-intercept of +2. So what we should have had for the vertex, you should have 0, 2. If you look, this vertex is in the valley. So if it's in the valley, you've got a minimum value. Your axis of symmetry, it's right here. It's your x-axis. So when we fold this in half, we're going to fold it across the line, x equal to 0. Your y-intercept, well, that's 2, b equals 2. Our zeros, they do not exist, or there's no solution. So for this, especially when there's something like this, you can also write ns, but does not exist. Is good too. ARN, well, it's all real numbers. So we can put any number into this equation, right? So, we can put 0 squared plus 2. Well, that gives us 2, which indicates why we have, the smallest number of 2. But we could put in a big number, right? We could put in, 1,500,000 squared. It's 2, and you get a number way up there. So our range, the smallest number we can get out of this math problem, this function, it's a 2. We just cannot get anything smaller than a 2 because mathematically it's just impossible. Well, let's look at our answers here. You should have had time to work this out on your own. So we have x squared plus 2. Well, our vertex is 0, 2. Try to make that neater. 0, 2. And our parabola looks like a valley. So valley still is, it's a minimum value. It's impossible, mathematically impossible to get a number smaller than 2. Our axis of symmetry, well, that's your x value, which is right here. And then anytime x is 0, that number that goes with that x, that's your y-intercept. So our y-intercept is b is equal to 2. We verify that by looking at the graph. The vertex crosses at 2. Your y-intercept will not always be at the vertex. Our zeros, well, there's no solution. The other words for that, if you remember, is roots. You got root, solution, or zeros. We're just putting zeros here, but you'll want to remember the words root and solution because they show up a lot. They do not exist. Does not exist. You could also write n/s for no solution. We can put any number into a quadratic, so your domain is always going to be ARN, right? All real numbers. In your range, our output, our answers. Our answers have got to be 2 or bigger. So once again, we have that bracket followed by parentheses. Your first number here is always going to be your smallest or largest number. And then next to it, is, unless we put limits on it, is going to be infinity. Parent function is being multiplied by -1. So this is really -1 times x squared. So if we plugged in, say, like -2, well, negative times a negative is a positive. A negative times a positive is a negative, so we'll wind up with negative answers, which is why our parabola now looks like a hill. So for a parabola looks like a hill, does it have a minimum or maximum value? But the work looks just the same. Here's your vertex. You're going to put your points of your vertex here. Whatever your x value is, it's going to be your axis of symmetry, the line that makes the fold in half. Your y-intercept, it's going to be where it touches. That's your b. That's a b, not a 6. B. Your zeros, it's where it touches or crosses the y-axis. So it's either going to touch it just once or it's going to cross it twice. Your domain, you should know this by now. And then your range is all the possible answers. What kind of answers are you going to get? Feel free to pause the video, work this on your own, and I'll be waiting for you on the next slide. So here's what I came up with. Came up with my vertex, 0, 0. When you're climbing a hill, walking on a hill, there's only so far you can go. There's a maximum height, there's a maximum height. There's a peak. Even if you're climbing Mount Everest, when you get to the peak, that's the maximum you can go. Your axis of symmetry, well, that's your x value, so x is equal to 0. It touches the y-intercept or crosses at y, so b is equal to 0. It has 1, 0, which is 0. You could have written it as 0, 0 if you wanted, or you could put it in the curly brackets. All three versions are correct. So again, all real numbers. The maximum number you can get is 0. So if you squared 0, you still get 0. And if you put -1 in, you square it, you get 1. But when you multiply that by -1, you're back in the negative world. Now we've got this one here, and it looks like our lattice points are a little bit better, but they're still not quite exact. But what we did is we're using the inverse. And remember, in mathematics, inverse just means opposite. So we're using the inverse of the parent function. Once again, the parent function is x squared. So we're taking the inverse of the parent function and we're adding 3 to it. So we get a new vertex. So write your vertex here. Your axis of symmetry is whatever that x value is. Your y-intercept is whatever that number is. Your zeros is where it crosses the x-axis. You can write as a couple of different ways you can write that. You can write it as ordered pairs. You can write it in brackets with your smallest number first, followed by your biggest number. So there's a couple of different ways you can write that. Your domain's what? I'm not even going to tell you because you should have that memorized. And what are your possible answers? What are your possible outcomes? Pause the video, figure this out, and I'll share with you the answers in just a second. So here we go. Our vertex is 0, 3. We establish that has a maximum value. Your axis of symmetry is just 0. Crosses your y-axis at 3. We have 2 zeros, and they're just right below the lattice point. If you look, if we use a quadratic formula, we could probably get it. But what we need to know for today is it's got 2 numbers. We put in all real numbers. The smallest possible number we can get out of this is 3. And we can get as big negative as we want. We'll stick with negative 1,500,000. Now let's look at this one. How does this compare to your parent function? That's right, it's thinner. So, but the work's going to stay the same. I think you should know what to do here. So go ahead, pause the video, think through it. And on the next slide, I'll give you the answers. So our vertex, it's 0, 0. We've seen that answer before. But our valley, the sides of our valley are much steeper. But since we're in a valley, we know we got a minimum value. Our axis of symmetry, still x is equal to 0. Our y-intercept is still 0. Since it touches the x-axis, we say it has one solution or one root, 1, 0, which is 0. You could also, once again, write it as an ordered pair or in brackets, all real numbers. And we can't get anything smaller than 0. No matter what number we plug in here, it's going to be bigger than 0. We got a few more to look at. So let's compare this to what we did just a second ago with the 4x squared. 4x squared was more narrow than the parent function of x squared. This one's going to be a little bit wider, but the work still works the same. So pause the video, find your vertex, find your y-intercept, axis of symmetry, your zeros are your roots, your solutions, your domain, and your range. So welcome back. Our vertex here, well, that's just 0, 0. We use our x value to write 0. X is equal to 0 for our line of symmetry. Your y-intercept, even though we got a flat graph, it crosses at 0. And our solutions, our roots, is just 0. I'm going to put it in the bracket. 0. Domain's all real number. The smallest number we can get is 0, but there's no maximum. So we're going to write 0 affinity. a lot of people think quadratics look like, because this is the kind of problem we use a lot in algebra. So notice we've got the x squared, we've got a middle term, and we got a constant. So ax squared plus bx plus c is our standard form. Your c is the constant. And your x squared is just your leading coefficient, bx is your middle term. But it moved the graph a little bit different. It's still on the, so our vertex is still on the x-axis, and it's going to be some number. Our axis of symmetry is still the x value, but notice we got a new y-intercept. It's not going to be, it's not at the vertex anymore. It's on the leg. It's on the curved part. It's this number right here, whatever that number is. And then we've got a different 0, but you're still going to write it. I want to maybe put mine as an ordered pair. And then your domain's still going to be all real numbers. And your range, bracket, smallest number, small, to whatever your biggest possibility is. So let's see what you can do here. Answers and compare them to what I came up with. For here, I got -1, 0 for the vertex. My parabola's a valley, so it's got a minimum value. My axis of symmetry, it's going to be this right here, right? On that little grid. So up until now it's been 0, but now it's -1. Our y-intercept, instead of being at the vertex like it's been, it's on one leg, one curve, whatever you want to call it, but it crosses the y-axis at 1. Our solution is down here. So that's -1, 0, or you can write it in your brackets as -1, either way, just one solution. Our domain, as always, is all real numbers, and we can't get an answer less than 0, but there's no maximum answer, right? We can come up with some really big numbers. We've got another one. It's x squared plus 2x minus 3. So find your vertex, your axis of symmetry, your y-intercept, your solutions, your roots, your solutions, your zeros, your domain, and what's your possible answers. And really, your range here, it's important to think about it because it helps build your number sense. And it helps build your intuition, and just improves your overall problem-solving skills. So don't think that's trivial. Pause the video, get your work done, and I'll be back in just a second with the right answers. Well, this is what I came up with. My vertex, -1, -4, it's this little point here. My axis of symmetry is, or x is equal to -1. You know, you go up this little where x is equal to -1. You can fold that parabola over. It intersects at -3. What else you notice? What other number is negative? A little hint, that's your y-intercept, your constant. Our zeros, well, we got a couple of good lattice points here. So it's -1, -3. Been better if this was written in brackets as -3, -1. -3, -1. Our domains, all real numbers. Our range is anything bigger than -4. Now we got, we're running out here. This is our last one. But if you can do these, you can do what's on our work. And hopefully you find this pretty easy because your vertex, that's your turning point. It's your highest or lowest point. In this case, we're climbing a mountain. Your axis of symmetry is whatever x is here. Your y-intercept is where it crosses the y-axis. You know your zeros is where it crosses the x-axis. That's also your roots and your solutions. Your domain is always going to be all real numbers, and that's all your possible answers. Let you work on this on your own. You should have time to complete it. This one, notice our vertex wasn't on a lattice point, so we're going to have to approximate it. So yeah, I mean, graphs are useful because they're able to, give us a rough idea. But one reason we want to get good with formulas and manipulating equations is sometimes we want a more exact answer. And in the real world, if you're like 1.5, like $1.50, well, that's more than $1.40. So if you're trying to figure out your cost on something or how much to sell something for, you want to be pretty precise. So graphs just help us visualize things, whereas number crunching, which we'll do later, gives us more exact answers. But if you've got something in this range, you're good. The x value from our vertex is 1.5. Once again, our vertex, since we're climbing a hill, has got a maximum value. Our y-intercept is 4. And then our zeros are good lattice points. -1, -4. Should have been written as -4, -1. Our domains, all real numbers. And our range, well, whatever number I use for my y, because that's my maximum, could be no more than that all the way down. And once again, depending on what you're working on, if you're an engineer, you may have like a greater, threshold for tolerance, or so your application in the real world will let you know if this graph suffice or should we actually crunch some numbers. But to recap, here's our recap. And all we did is we just looked at the parabola. Our x-intercepts are anywhere across the x-axis, x-intercepts. So on this one, it's -1, 0, 3, 0. Our axis of symmetry, it cuts our parabola in half. Our quadratic, we have 1, we may have none, 1 or 2 solutions. So this one has 2 solutions. The solutions are roots, so this one is -1 and 3. The vertex is it's either the bottom of the valley or it's the top of the hill. This graph here, it's a valley, so it has a minimum value. Our axis of symmetry is the x value. It cuts it in half here at 1. And our y-intercept is 3. Once you get it, this should get you through your online practice and your independent work. If you need help, let me know.